Today we are going to focus on combination reaction with many examples. But before this, what is combination reaction? We can define this way. When two or more than two elements or compounds combine to form a single compound, then the reaction is called combination. And it is also called addition or sometimes called synthesis reaction. What it means exactly is its structure is like this. Maybe element is combined with another element, or maybe three elements are combined with each other to form compound, or maybe an element combined with compound to form new compound, or maybe two compounds or more than two compounds form one single compound. What it means? There are many reactants, maybe two or more than two, but product is only one. I want to give you many examples. Number one, potassium when combines with chlorine, they form potassium chloride. Remember that when chlorine combines, then we'll write chloride. If instead of chlorine it was nitrogen, then we'll write potassium nitrite. If it was oxygen, then we'll write potassium oxide. Okay, now how to write balanced chemical equation of this chemical equation? Potassium is an element, its symbol is K. Chlorine is another element, but it is diatomic element. That's why we cannot write symbol. We have to write Cl2 because it is diatomic. And when these two combine, then we have to write K for potassium, and chloride means Cl. And this is a compound, and whenever any compound forms, then we have to exchange the valency. Potassium is valency is 1, chlorine is valency is 1, equal valency, no exchange. This is correct formula equation, but not balanced. While balancing a chemical equation, I suggest you to start from the right hand corner. At this time we have chlorine at right corner, so here chlorine is 1, but here chlorine is 2. That's why I am taking 2 here. And chlorine is balanced. Now a ton of potassium, potassium 2, potassium here 1, so I have to put here 2 to balance the equation. This way we can balance the equation. Let's take another example of combination reaction. Magnesium when combines with nitrogen, then they combine with each other to form magnesium nitride. Now how to write chemical equation? Mg for magnesium, nitrogen is diatomic, that's why we have to write N2, not only N. And when they combine, then magnesium Mg, nitride means nitrogen is combined. Now we have to exchange the valency in this compound. Magnesium valency 2, nitrogen 3. So valency of magnesium should be given to nitrogen, and nitrogen should be given to magnesium. This way, the molecular formula of magnesium nitride is Mg3N2. This is correct formula equation, but not balanced. And whenever we have to balance an equation, I suggest you to go through right hand corner. Look at this, nitrogen 2, here also 2. So nitrogen is balanced, but magnesium 3, if we take here 3, then magnesium also balanced. Okay, this is balanced chemical equation. Now third, sodium when combines with oxygen, certainly sodium oxide forms. And sodium symbol Na, but oxygen it is diatomic O2, and when they combine Na for sodium and O for oxygen, we have to exchange the valency, sodium 1, oxygen 2. So 2 of oxygen should be transferred to sodium, but 1 of sodium should not be given to oxygen because oxygen itself is 1. This is correct formula equation. Now we have to balance. Look at this, oxygen 1, here it is 2. So I am taking here 2, and it makes sodium 4, 2 2 are 4. So we have to take here 4, and it is balanced. Now fourth, carbon plus oxygen, carbon dioxide. Symbol of carbon is C, but oxygen is diatomic O2, and carbon dioxide, it will be better to remember the formula of carbon dioxide. We know this, CO2, and so we don't have to go through transfer of valency. Okay, it is balanced chemical equation. Now let's go to another one. Aluminium plus nitrogen, Al for aluminium, and nitrogen is diatomic, that's why we have to write N2, and aluminium nitride, Al for aluminium, nitride means N. Both of them have the same valency, that is 3. And so equal valency, no exchange. This is correct formula equation, but not balanced. Nitrogen here 1, here it is 2. so we have to take here 2, and aluminium is now 2, and here we have to take 2, and 2Al makes the equation balance. Let's take some other example also. Sodium combines with chlorine to form sodium chloride. Na for sodium, and chlorine is diatomic, that's why Cl2. When sodium combines with chlorine, then sodium chloride. Na for sodium, chloride means Cl. Both of them have same valency 1, equal valency, no exchange. Correct formula equation, but not balanced. Chlorine 1, chlorine 2. So we have to take here 2, and it balances chlorine. And sodium 2, here 1. That's why we have to take here 2. Next, nitrogen when combines with hydrogen, they form ammonia. Nitrogen, it is diatomic, that's why N2. Hydrogen also diatomic, we have to write S2. And when they combine, they form ammonia. We know the formula of ammonia, it is NS3. Valency of nitrogen, that is 3, is given to hydrogen. Valency of hydrogen is 1. Nitrogen itself is 1. That's why we don't have to transfer one valency of hydrogen to nitrogen. Let's balance the equation. Hydrogen 3, hydrogen 2. This is odd number, so I'm taking here 2 to convert it into even number. 3 2 6 hydrogen. Now here 2, so we have to take here 3 to balance hydrogen. 3 2 6, both the side we have 6 hydrogen atoms. Nitrogen 2, nitrogen 2, it is balanced. Now next, iron plus oxygen, iron oxide. Iron symbol Fe, oxygen diatomic, that's what O2. Oxide means oxygen O, and iron is valency is 3, should be given to oxygen, and oxygen's valency is 2, should be given to iron. Now this is correct formula equation. We have to convert it into balanced chemical equation. Here oxygen is 3, here oxygen 2, here odd number, here even number. I suggest you to convert odd number into even number, taking 2 in front of this iron oxide. 3 2 6, number of oxygen atom is 6 in right hand side. If we take here 3, then it balances oxygen. 3 2 6, 3 2 6. Iron 2 2 4, here we have to take 4, and it balances iron also. This is balanced chemical equation. Now next, quicklime plus water gives slacklime. Quicklime, we have to remember, it is calcium oxide, and both of them have valency 2, so no exchange. And water, we know its formula is S2O, and slacklime means calcium hydroxide, and calcium is valency is 2, hydroxide 1 we don't have to transfer to calcium, but valency of calcium is 2, which should be given to hydroxide. Hydroxide is a radical, that's why whenever we give valency to a radical, then we have to put that radical into bracket. So CaOH whole 2. This is balanced chemical equation. Hydrogen 2, oxygen 2, 1 plus 1 2, calcium 1, calcium 1. Let's go to another reaction. Ammonia plus water. Ammonia dissolves in water and they react with each other to form ammonium hydroxide. So we are writing ammonia's formula is NH3, water's formula is S2O, and ammonium hydroxide, ammonium NH4 hydroxide OH. Both of them have equal valency 1. So we don't have to transfer valency here. And this is balanced chemical equation because hydrogen 4 plus 1 5, here also 3 plus 2 5, oxygen 1, nitrogen 1, nitrogen 1. Now let's go through other example also. Look at this. When gold reacts with chlorine, let's say only reactant side is given, you have to find out product also. How can we do it? Gold is Au, symbol is Au, and chlorine, it is diatomic, that's why Cl2. When gold combines with chlorine, its valency is 3. Gold has two different valency, it has variable valency, sometimes 1, sometimes 3. Normally its valency 3 is taken and it is called auric, and if 1 is taken, it is called aurous. Here it is auric chloride, that's why Au for gold and Cl for chlorine, and valency of gold is 3, chlorine is 1 we don't have to transfer. AuCl3, its name is auric chloride. Now it's time to balance the equation. Here we have 3 chlorine, here 2. That's why odd number should be converted to even number, taking 2 in front of this chlorine. 3 2 6. we have to take here also 3, 3 2 just 6. Both the side chlorine is equal. Now Au gold, here it is 2, here only 1, so we have to take 2 here. Now another example, when lead combines with oxygen, then what they form? Lead is Pb, oxygen diatomic O2, and when they combine, then PbO. Both of them have equal valency 2 2. That's why no exchange, and this is correct formula equation, and the name of this compound is lead oxide. That's why I'm writing lead oxide. Now balance the equation, oxygen 1 oxygen 2. If we take here 2, then oxygen is balanced. If we take here 2, then lead is also balanced. Now let's go to another, hydrogen plus sulfur. What they form? Hydrogen diatomic S2, sulfur it is monoatomic, not diatomic, that's why only S. When hydrogen combines with sulfur, then we have to write S and S, and hydrogen valency 1 we don't have to transfer, but valency of sulfur is 2, we have to transfer it to hydrogen, S2S, and name of this compound is hydrogen sulfide. Now we have to balance the equation, sulfur 1 hydrogen 2 hydrogen 2. This is balanced chemical equation. Now let's go to another, carbon plus hydrogen. What they form? Carbon symbol C, hydrogen its symbol is S, but it is diatomic, that's why we have to write S2. Carbon is not diatomic, that's why we are writing C only. When they combine, then we have to write C and S. Carbon is valency is 4, hydrogen is valency is 1. We don't have to transfer 1, but carbon valency 4 should be given to hydrogen, CS4. This is methane. And we have to balance the equation, hydrogen here 4, here only 2. If we take here 2, then hydrogen is balanced, carbon 1 carbon 1. Okay, now let's go to another, hydrogen plus oxygen. This is very simple, it gives water, and hydrogen S2 it is diatomic, oxygen O2 is diatomic, and what is water? S2O. Now we have to balance the equation, oxygen 1 oxygen 2. If we take here 2, then oxygen is balanced, hydrogen 2 2 are 4. If we take here 2, then hydrogen is also balanced. This way we can write the combination reaction and we can balance the combination reaction. I gave you many examples. I think these are very common combination reaction and they are frequently asked in the examination. Okay, next class we'll meet with some other matter. Thank you.